Evaluate the limits of the equation or function in closed form. Note that each of these functions is already in closed form. The first thing we will attempt to do is to simply plug in the number a. For part a is 1 at x equals to 1. We see that this is 1 squared minus 2 times 1 plus 1 over 1 squared minus 1, which is 2 minus 2 is 0 over 1 minus 1 is 0. If we have 0 over 0, this is not good. But at least it tells us that we need to do something else. And that something else is most likely we will need to factor this. And so we will rewrite the limit at x equals to 1, but this time we will factor both the numerator and the denominator if possible. In the numerator, x squared minus 2x plus 1 can be factored at x minus 1 times x minus 1. And in the denominator, we factor out x only. We still have x minus 1 as the factor. We then canceled out 1x minus 1 factor and rewrite this expression. The limit at x equals to 1 of x minus 1 over x. At x goes to 1, the term goes to 1 and the term in the denominator goes to 1. And so this is 1 minus 1 over 1, which is 0 over 1. 0 over 1 is definitely 0. So this limit is 0. For part b, we will do the same thing. We will plug in 0 into this expression to see what happens. 0 squared plus 0 over 0 squared plus 2 times 0, which is 0 over 0. Again, with 0 over 0, we will need further analysis, and that is, we will need to do something else. And that something is, again, most likely factoring. Factor h in the numerator, we have h plus 1 times h. Factor h in the denominator, we have h plus 2 times h. What the top and the bottom have in common is a factor of h, and so we would cancel h out. We end up with the limits at h go to 0 of h plus 1 over h plus 2. And then we attempt to plug in the numbers again. As h go to 0, the term go to 0, and h go to 0. And again, what allows us to do this is this notation here. Without the limit notation, we would not know whether to make this h go to 0 or not. And so it is important to keep writing the limit notation in front of the expression here. What we end up with is 0 plus 1 over 0 plus 2. No need to write the limit notation now because h is no longer in the expression. Simplifying this, we have 1 over 2, which is the limit of the given limit problem.